Okay, so let us continue and let us now understand the Solidity code. So you all are already familiar with this. You all have already implemented all assignments, completed your mini project. But as it's a part of your theory course also, let us quickly understand this or quickly go through it. So here is an example of basic Solidity code. So I'm not going to go into detail of it, but just to give you a feel of it. Standard object Solidity is basically it's a standard object oriented programming language which is similar to JavaScript. So a contract is defined here, and you can import other contracts also. So you can refer to other smart contracts. So in this case, you are actually importing a key value store here. So KV store contract here, and you can have a transaction events. So these events will be emitted when the transaction executes, and so if you this is the definition of event, and within the function this is a smart contract function that is going to get invoked in a transaction. You can also fire this transaction. So at the different point of the function execution, you can fire the transaction event. So then you could have a modifier function. This ensures that the execution proceeds only if the predefined conditions are met. Now let us understand some patterns of smart contracts. So because you want some of these properties, it has been deliberately restricted. So what are some of the patterns? Okay. So the data and the logic can actually span multiple contracts. Typically there could be 5 models here. So let us understand these 5 models. So first one is a database contracts. So these database contracts are used only as a data storage. The only logic they need is functions that allow other contracts to write, update and get data, and some simple way of checking the caller permission, that whatever those permissions may be. Okay. Then we have a controller contracts. So these contracts actually operates on the storage contracts in a flexible system, that both controllers and databases can be replaced by other similar contracts that share the same public APIs. Although this is not always required, the controllers can be advanced and could, for example, do the batches read writes or read from and write to multiple different databases instead of just one database. Then the third one is a contract managing contracts or CMCs. The purpose of this contract is only to manage other contracts. Their main task is to keep the track of all the contracts or components of the system, handle the communication between these components, and to make modular design easier. So keeping this functionality separate from normal business logic should be considered good practice, and it has a number of positive effect on the system. Then the fourth one we have is the application logic contract or ALCs. The application logic contract contains application specific code. Generally speaking, if the contract utilizes controllers and other contracts to perform application specific tasks, it's an application logic contract. Then we have a utility contracts. So this type of contract usually they perform a specific task and can be called by other contracts without restrictions. So it could be a contract that hash the strings using some algorithm, provide random number or other things, and they normally don't need a lot of storage and often have a few or no dependency.